All right, this is Math 209, Week 3. We're going to be doing Section 7.7, Solving Proportions. So when you have a fraction equaling another fraction, there's a couple of ways to solve it. In the previous video, I showed you the cross products method. So you got the x over 24 is equal to 5 over 6. And we know that the cross products will be equal. So this means 6 times x will equal 24 times 5, which means 6x is equal to 120. And then we divide both sides by 6. It makes the 6 go away, so you get x is equal to 20. All right, so now we know that x is equal to 20. Now that's one way to solve this problem. Another way to solve this problem, it was x over, was it 24? Yeah, equals 5 over 6. Now another way to to solve this problem is look for a horizontal relationship. And I see a horizontal relationship. I see that 6 times 4 equals 24. So that means I'm going to do 5 times 4, and that gives me 20. Since 4 times 5 is equal to 20, that means x must equal 20. All right, so sometimes one way is way shorter than the other way. I call this using logic. You know, you're looking for a horizontal relationship, while this is called the cross products method. Right here you got two ways to solve this problem. It's a fraction equaling another fraction, so you can definitely use the cross products method. All right, so the cross products method says 6 times 25 is going to equal 30 times x. All right, and so 6 times 25 is 150, and 30 times x is 30x. We're going to divide both sides by 30. So the 30 goes away, so you get x is equal to 5. So x is equal to 5. Now, the other way we could have solved this problem is 6 over x is equal to 30 over 25. And what we could have done is we could have said, well, what's the horizontal relationship? Well, I see that 6 times 5 is 30. So that means something times 5 is equal to 25. These numbers are always going to match, right? So if this is times 4, then this is times 4. Since this is times 5, this is times 5. So something times 5 has to equal 25. So that tells you that x must be 5, because 5 times 5 gives you 25. So take a look. Sometimes the algebra is quicker, sometimes using logic is quicker. All right, so we have one fraction equaling another fraction. So 21 over 6 is equal to 7 over x, so that means we can use the cross products method. So we get 21x is equal to 42. Divide both sides by 21, so the 21s go away, and you get x is equal to 2. All right, so that's one way. Oopsies, that's one way. But the other way we could have done it is 21 over 6 is equal to 7 over x. Another way to think about it is, let's see, 21 divided. All right, so we have one fraction equaling another fraction, so we could use the cross products method. But on this problem, I'm going to really just tell you, hey, look for the logical method, because the logical method is easier on this problem. Because look, 14 times 8 is 112. So 13 times 8, 24, 8, 9, 10, is 104. So that means h is equal to 104, and we're done. Boy, there's no we didn't have to use algebra on this one. If we were going to use algebra, we would have had to multiply 13 times 112, and then we would have had to divide by 14. Simply multiplying by 8 is a whole lot less work. So on this one, we have a fraction is equal to another fraction, and I'm going to tell you on this one, it really looks like the algebra method is probably the easier of the two methods. So we're going to do the cross products. So you've got 8 times 2 is going to equal 5 times 3z. So you've got 16 is equal to 15z. We're going to divide both sides by 15 because we want to get z all by itself. So the 15s go away, and you get z is equal to 16/15, and that is your answer. All right, so when you have a statement like this, 3 is to 4 as 7 is to x, you have a choice. Now you know that you're going to put it in an equation that looks like a fraction is equal to a fraction, all right? And so when it says 3 is to 4, that means you can go 3 is to 4. And then once you've decided on the order, so 3 is going to go on top, 4 is going to go on the bottom, as, so that's your equal sign, 7 is to x. So since we went top over bottom, so that means 7 is going to be on the top, and then the x is going to be on the bottom. 7 is to x. And we can see, oh, look at this right there. There's our answer. 3 is to 4 as 7 is to x. Now, believe it or not, this is not the only option we could have had. We could have said, let's see, I'll do another set of fractions. Instead of doing it top and bottom, we could have done left and right. So it says 3 is to 4. So we could have said 3 is to 4, and then as 7 is to x, as 7 is to x. So this is another option that we could have done. It wasn't one of our choices, so we didn't have to worry about it. But just to let you know that you can either write your proportion up and down, or you can write your relationships side to side. So what they're saying here is they're saying we've got these two rectangles, and this smaller one has been, this larger rectangle has been shrunken perfectly to equal this one. And so we're supposed to figure out, well, if 9 has been shrunken to 6, what does 6 get shrunken down to? All right, so the way we're going to think of this is as a proportion. So here we're going to set up our fractions, and we have a choice. So take a look here, and you'll see that 6 is to 9 as x is to 6, right here. So kind of like 6 is to 9 as x is to 6. So I'm going to write 6 is to 9 as x is to 6. So 6 is to 9, 6 is to 9 as x is to 6, as x is to 6. And now we've got one fraction equaling another fraction, so that tells us we can use our cross products. So what does that tell us? That tells us that 9x is equal to 36. So now we can divide both sides by 9, so the 9's go away. So you get x is equal to 4. So that tells us that x is equal to 4. So I want you to notice, one of the things I want you to notice, a lot of students think, and they're wrong, that, oh, because 9 minus 3 is 6, that means I can do 6 minus 3 and get, oops, the answer is not 3, like 6 minus 3 is 3, but the real answer is 4. And that's because proportions, things that are in proportion, they don't change by addition or subtraction. They change by multiplication and division. So here's another problem. This is a proportion problem. So it says if 3 sweaters cost $32.37, how much would 9 sweaters cost? So what does that mean? So what that means is you could think of it like a table. you could think of it as a table, and you can say sweaters, and you can think of cost. And you can say, well, 3 sweaters cost $32.37, so 9 sweaters cost how much money? Now, once you've got this little picture here, this table tells you your proportion. 3 over 9 is equal to 32.37 over x. All right? So you can think of it that way. And now, hey, we've got a fraction equaling another fraction. So that means we can use our cross products. So we get 3x is equal to, now I'm going to have to multiply $32.37 times 9. And I get 291.33. And now I'm going to divide both sides by 3, so the 3's go away. So I get x is equal to, now I'm going to do $291.33, and I'm going to divide by 3, and that gives me 97.11. So how much do 9 sweaters cost? It's going to be $97.11. And that wraps up this video.